All right, so we're going to finish up today section 2.2. Okay, it's the third part. So the first day we looked at how to find the coordinates of the quadrantal angles. Those all have the 0, 1, or -1. Yesterday we looked at how to find the coordinates of angles that are either 30, 45, or 60. Kind of gave you a little preview of what happens if you do it in quadrant 2, but that's what we're going to focus on today. What happens if the 30, the 45, or the 60-degree angle is in one of the other quadrants? So in other words, it would be a multiple, like 120 or 150. And so we'll look at how to do that. So the idea is you're still using the basic triangles that we did yesterday. We don't have to go through and use Pythagorean theorem and figure out all those coordinates again, because it's going to be the same triangles we had. They're just going to be mirror imaged or flipped into other quadrants. So the numbers we're going to be using today are 3 over 2, 1/2, and root 2 over 2. Same numbers. Only thing that happens when you mirror image it into another quadrant is it can become a negative. Definitions for the sine, the cosine, and the tangent, like y, x, and y over x, that's exactly the same too. So we'll practice a little bit more with unit circle trig. And then we'll finish up with looking at what happens when we have to evaluate an angle that's not a multiple of 30 or 45. Okay? And that's where we're going to use the calculator. And I'll show you guys how to do that. All right. So there really isn't anything new for me to explain. You should be able to just jump right into a problem. This is the only one today that we're going to do all 6. The rest of the problems we do, it's going to be set up to just find one of the 6, like the worksheet from last night. All right, so find the 6 trig functions of 135. So first thing we want to do is figure out where 135 is, roughly on the circle. Let's just start by kind of narrowing down the quadrant it's in. What quadrant is 135, Ethan? 2. Yeah, it's in quadrant 2, and you're always going to have 3 choices for where it could be. It's either right in the middle, it's going to be closer to one side, or it's going to be closer to the other. So where's the 135? Yep.
In the middle.
It's right in the middle. So 135, right there. Now, when you have 135, we have to figure out if that's a multiple of 30 or if it's a multiple of 45. Which one is it a multiple of?
45.
Yep, it's a multiple of 45. So what that means is when we draw the triangle, okay, I'm going to draw it off to the side so it's easier to see. Okay, there's my triangle. How long is each side in the 45, 45, 90 triangle? This is one of the 3 fractions we have to remember. Yeah, Jason?
They're all the same one.
What's that?
They're all the same one.
Well, the 2 legs are the same, but what are they exactly? Yeah, do you remember? No, Emma?
Root 2 over 2.
They're both root 2 over 2. That's the lengths of the sides in a 45, 45, 90. But what we have to remember is we're in quadrant 2. So we're going to go left and then up. So we have to take into account when we write the coordinate that we're going left. So what do you think that means the coordinate for 135 is going to be? Caitlin?
Negative.
So what's my x value?
Negative root 2 over 2.
And what about my y value?
That would just be root 2 over 2.
Just root 2 over 2. That's the coordinate for 135. Negative root 2 over 2 because we went left. Positive root 2 over 2 because we went up. Why is it root 2 over 2? Well, that's what we did yesterday. So it's the 45, 45, 90 triangle, mirror image from quadrant 1. It's just a flip, that's all it is. All right, now that we've got the coordinate, we've got the x, we've got the y, we can go through and do what we've been doing all week. Okay, find the 6 trig functions. All right, so let's find it. Dylan, what would be the sine of 135?
Square root of 2 over 2.
Yep, that would be my y value, which is square root of 2 over 2. Does make a difference if you accidentally flip them, because they're not the same. So if you mix up the x and the y, it's going to mess things up. Yep, well. All right, so we got the sine. Devin, how about my cosine?
It'll be negative square root of 2 over 2.
Yep, that's the x value. So the cosine of 135 degrees is negative square root of 2 over 2. And what about, Tyler, what about my tangent?
It's square root of 2 over 2 divided by negative square root of 2 over 2.
Yep, and what do you get when you divide those two numbers?
Square root of 2 over 2.
Well, how do these two numbers compare to each other? Square root of 2 over 2 and negative square root of 2 over 2.
They're the same, so it'd be negative 1.
Yeah, they're opposites. Right? Whenever you divide two numbers that are opposites, it doesn't matter what they are, you're always going to get negative 1. Okay. Now, we're really done with that coordinate. We don't have to go back to it to do anything else. We have to get these last three, but we're just going to take each one of these, and what are we going to do with them? We're just going to flip them. Yep, so we'll flip them. Anyone remember what you get when you flip root 2 over 2 and you fix it to get the final answer? Gina? You just get root 2. Yep. Is there any question? I know we've gone through it a couple times, but anyone want to see how you get root 2? So remember, when you flip it, you're going to have 2 over root 2. But you can't leave it like that, so you're going to multiply the top and the bottom by the square root of 2. And you go straight across. 2 square root of 2 in the top. And in the bottom, square root of 2 times square root of 2 gives me square root of, square root of 4, but that's just 2. And then the 2's cancel. So that's how you get the square root of 2. Haley, how about the secant of 135? Oh, wait, we have 2 Haleys?
No, sorry, I thought you said Hager.
Oh, okay, I'm sorry, yeah, Haley.
Would it be negative square root of 2?
Yeah. The only difference between the sine and the cosine is one's positive and one's negative. That's going to be the same difference between the cosecant and the secant. One's positive, one's negative. So negative square root of 2. And Tyler, how about my cotangent?
Negative 1.
Yeah, negative 1, that's one of the numbers you can flip and it stays the same. There's 2 numbers you flip and they don't change. 1 and negative 1. Okay. And that's our 6 trig functions for 135. Questions on that one? All right, let's try this one. This time they just want to know one thing, just the cosecant of pi over 4. Okay, before you're even ready to find the cosecant, there's something else you got to figure out first. What do you have to find first here? Yeah. So here's the angle. So Haley said find the angle. That's the angle, pi over 4.
We can find the degrees.
1 degree.
Okay, we could change it to degrees if necessary because we ultimately need to find what? The what? The coordinate. That's what you need. If you know the coordinate, you can jump right to the coordinate from this, then you're all set. If you can't, then maybe you change to degrees first and that helps you. Right? So, cosecant of, what's pi divided by 4? Yep.
45 degrees. degrees?
45 degrees. Pi, you multiply by 180 and you divide by pi, and that converts it. Okay, so now we got 45 degrees. So we're going to look at where that is. Ryan, what quadrant is 45 degrees in?
It would be in the first quadrant.
Yeah, it's the first quadrant, right in the middle, or off to one side a
Dead
little
in the
bit?
center.
Yeah, right in the center. 45 degrees. So since it's a 45 degree angle, this is definitely a 45, 45, 90 triangle. And Justice, how long is each side in the 45, 45, 90? Or each, I'll say each leg.
1.
The hypotenuse is 1. But each leg is... Same thing they were in the last problem. Richard, Kavani, can you remind us how long each leg is?
Square root of 2 over 2.
Square root of 2 over 2. Alright, now, do we have to worry about either the x or the y being negative in quadrant 1? Okay, no? No? No. Okay, we don't have to worry about it because we're going right and we're going up. So what would be my coordinate for 45 degrees? Yep, right?
Square root of 2 over 2, and then square root of 2 over 2.
Okay. So now we've got the coordinate. We just have to figure out the cosecant. Alright, so cosecant is when we flip the y. And Jason, what do I get if I flip the y value?
You get 2 over square root of 2.
Yep, and then when you fix that, what do you end up with?
You end up just the square root of 2.
Just the square root of 2. Yep. And we just went through that in the last problem, how to get the square root of 2. Okay, and that's it. So that's kind of that's a review from yesterday. Questions on that one? Okay. Let's try this one. Sine of 225. Okay, so Ariana, what quadrant is 225 in? Which one? So fourth, that one would be over here. So remember, the fourth quadrant starts at 270. It's in the third. Right in the middle or off to one side?
Would it be to the left, like closer to the middle?
Well, let's look at 180. If you look at 225, how far away is 225 from 180?
So would it be middle then?
Yeah, it's right in the middle because that's 45 degrees away from 180. So that's how you figure it out. Okay, so right in the middle. Basically, any angle that we're dealing with on a unit circle that ends in a 5, it has to be a multiple of 45. Not saying every number that ends in a 5 is a multiple of 45, but the ones that we are using on the circle have to be. All right, so 225. John, how long is each side in our 45, 45, 90?
Square root of 2 over 2.
Yep, both square root of 2 over 2. And now just be careful when we write the coordinate, we have to make sure we write a coordinate that's in quadrant 3. So what would be my coordinate for 225? Ethan?
Negative root 2 over 2. Negative root 2 over 2.
Yep, so in quadrant 3, they're both negative. So we've got our two values, and now they want to know the sign. So Gina, what's the sign of 225?
Negative root 2 over 2.
Yep, and which one did you pick, just so we know? Yes, the y. They're the same, so if you mix them up, you'd be okay here. But again, you really don't want to mix them up. Okay, so notice all these problems, we're not even using a calculator yet. Okay, because they're all going to ask for the exact answer. So whenever it says exact answer, you don't want to change that to a decimal. Okay, a decimal would be marked wrong. So just leave it just like that. Okay, questions on that one? All right, let's try this one. Okay, cosine of 7 pi over 4. All right, how about Natalie? What might I want to do first here? And why would you change it to degrees? What would that make? What's that going to help you to do? Right, you've got to find the coordinate. If you know the coordinate already, good, just go right to the coordinate. If you don't, change it to degrees. So you're going to multiply by 180 and divide by pi. So that's going to be 7 times 180 divided by 4, and that's going to give you 315. Now, we figure out where 315 is, figure out if it's a 30-60 triangle or if it's a 45-45-90. Mio is 315. It's in the fourth quadrant, in the middle, or closer or off to one side. Right in the middle. 315 is exactly 45 degrees before 360. So since it's 45 degrees away from 360, it's also 45 degrees away from 270. It's right in the middle. Draw your triangle. And now, the goal is to figure out the length of this side and the length of this side. But we don't even have to calculate them because we already have that number hopefully memorized. So how about, Dylan, what's the length of each side in this 45, 45, 90?
Square root of 2 over 2.
Yep.
Negative square root of 2 over 2.
So this is square root 2 over 2. That's square root 2 over 2. So when I'm labeling there, I'm just putting how long each side is. But then when I write the coordinate, I have to take into account if I went left or down. And Dylan did that perfect. Negative on the y. 2 over 2. Negative root 2 over 2. And Devin, what's my cosine?
Would it be square root of 2 over 2?
Yep, cosine is the x value, which is root 2 over 2. All right, so we've gone through the 45-degree angle now in each quadrant. Okay, but you can have a 45, a 135, 225, or 315. And for each one of those angles, there's 6 questions I could ask you. The sine, the cosine, the tangent, the cosecant, the secant, or the cotangent. And so it's really 24 different possible questions about 45-degree angles. Questions on 45s? All right. Now, 45s I think are a little easier because you can't really mix up the numbers in the coordinate. They're both root 2 over 2. The only thing you have to worry about is if they're the negative. But when we deal with angles that are multiples of 30, we're using the 1/2 and the root 3 over 2, but we got to get them in the right order. Okay. All right, so let's look at tangent of 120. So Tyler, where is 120 on the unit circle?
Second quadrant.
Yep, it's definitely in the second quadrant. So I'll put a couple labels in here. And is it right in the middle? Closer to 90 or closer to 180?
Closer to 90.
This one's closer to 90. It's not right in the middle. It's 30 degrees past 90, and it's 60 degrees away from 180. So I kind of exaggerated it, but it's closer to 90. All right, make your triangle. And as long as you draw it somewhat accurate, you should be able to see a short side and a long side. In this type of triangle, the short side is always how long? Yep, right?
Is it 1/2?
Yep, the short side is always the 1/2. And what about the long side? Justice?
Square root of 3 over 2.
That's always the square root of 3 over 2. So you never have to worry about any other numbers than 1/2, root 3 over 2, and root 2 over 2. Those are only 3. Alright, so now we know the x and the y. Just make sure we write a coordinate that's in quadrant 2. Alright, so Haley, what would be my coordinate for 120 degrees?
Would be negative root 3 over 2, comma 1/2. Or would it be negative 1/2?
Well, which one of those is the horizontal?
Oh, it'd be negative 1/2,
Yeah.
and then it'd be root 3 over 2.
Yeah, negative 1/2 root 3 over 2. Now, if you switch them, like let's say you could end up with the coordinate for 150. That's negative root 3 over 2, comma 1/2. Right? So, but that's what you want. Negative 1/2 root 3 over 2. And tangent. Tyler, what's my formula to find tangent?
It's y over x.
All right, so yeah, tangent not as easy to do in your head because you gotta use a fraction. So there's y divided by x. And Caitlin, when I divide those, what's gonna cancel?
The 2's.
Yep, the 2's, because you could flip and multiply. That's how you normally divide two fractions. So let's just cancel that. And Allie, what am I left with when I divide those two fractions?
Square root of 3 over negative 1.
And when you divide a number by negative 1, what does that do to it? It just makes it negative, yeah. So we can just put negative square root of 3. It's like if you had 4 divided by negative 1, you just put negative 4. Okay, any question on that one? So again, this angle, there's 6 questions I could ask you about it. The sine, the cosine, the tangent, the secant, the cosecant, or the cotangent. This time I just chose tangent. All right, so any angle that we do, there's 6 questions about that angle that I could ask. Okay, secant of 690. So it's already in degrees for people that like to think in degrees, so that's good. But what's not great about that angle? Ethan?
It's really big.
Yeah, it's too big. The bigger it is, it's harder to think about where it would be on the circle. So what can we do to make it smaller, but it won't mess up the answer if we do this? Yeah?
Subtract 360.
Yeah, we can subtract 360. All that subtracting 360 does is bring you back to the exact same spot 1 revolution earlier. Okay? But that's the key. We have to go back to the exact same spot. So minus 360, and that's 330. Okay. So 330. How about Noah? What quadrant is that in?
That is in the 4th quadrant.
Okay, so it's 270. That's 360. Right in the middle, closer to 360, closer to 270.
Closer to 360.
Closer to 360. It's only 30 degrees away from 360. So closer to that. Make the triangle. Draw your hypotenuse in to the origin. There we go. Put that in there. And again, if you draw it somewhat accurate, it's pretty easy to see where the short side is and where the long side is. All right. So how about Ariana? How long is the blue side? So the hypotenuse is 1. So, but your traces are root 3 over 2, root 2 over 2, or 1/2.
Root 3 over 2?
Yep, the long side is always root 3 over 2. And the short side is always 1/2. So now we know the x and we know the y. Just make sure we take into account that you went down and not up for the y. Alright, so John, what's going to be my coordinate for 330 degrees?
It would be square root of 3 over 2 negative 1/2.
Yep, perfect. Not that the negative really matters in this problem because we're looking for secant. Secant is when you flip the x. So even if you forgot the negative, you'd lose points because you'd get the coordinate wrong. But you could still get the secant right because the secant only depends on the root 3 over 2. Alright, so take the root 3 over 2 and flip it. And Emma, do you remember what you get when you flip root 3 over 2?
Would it be 2 root 3?
So that's, yep, your numerator.
Root 3 over 3.
And what goes in the denominator?
3.
3. So it's 2 root 3 over 3. If you wrote it as 2 over the square root of 3, you just didn't finish simplifying. Okay. Any question on that one? All right. So, I mean, there's 3 points in every quadrant we can do. The 30, the 60, and the 45. There should be another one that's very similar. Does anyone feel like we need to go through another one of those? All right. So let me show you a diagram that basically has every one of these points on it at the same time. All right. So it looks like kind of a lot, but there's really some patterns you can look for. We've already been using the patterns, so it's not a lot to really memorize. So if you look at this diagram, everything in this diagram is what we've been doing. These are the only 3 things you have to remember. The root 3 over 2, the root 2 over 2, and the 1/2. The blue triangles are all your 1/2 root 3 over 2s, mirror imaged into every quadrant. When you flip it, the coordinate doesn't change. Well, the number doesn't change. You just have to sometimes put a negative in front of the x, the y, or both. So every problem we do for unit circle trig is always one of those 3 coordinates. Sometimes there's a negative in there. That's it. The ones that we talked about on the first day, these are special cases. And those all have to do with angles that are right on the axis. 0, 90, 180, and 270. So if we look at it, you got a total of 3 points in every quadrant that you can do, plus the 4 right on the axes. That's 16 different points on the circle, and there's 6 questions I could ask you about each one of those points. So basically 16 times 6 is the number of different types of questions you could see. You'll probably have about 10 on the test, and they'll be just like this. They'll give you a trig function, give you an angle, and you got to do 2 things. Write the coordinate, and then write the answer. All right. Any questions on that idea? All right. So if you look at it, let me just kind of erase that and just zoom out a little bit. Those angles that we've learned about, they're not really equally spaced. It almost looks like there's a gap here where there should be something else, and then another gap there. You guys see what I mean? There's like these gaps here. Anyone have a guess what angle this would be? That's 15. Well, we don't look at 15 in this class. in pre-cal, we look at the 15s. But that's what's missing from the unit circle, all the 15s. And there's one of them, you know, over here, 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 and here. And now, if you include the 15s, you have, what is that, 1, 2, 3, 4, you have 5 points per quadrant. That gives you a total of 20 points in quadrants, all equally spaced now. Okay, but the 15s are what's missing from what we're doing. All right. So, what happens if we have an angle that's not a multiple of 30 or 45? Well, you're not going to be able to use unit circle trig. Technically, you can with the 15s. That's not something we're doing. So how do we figure it out if it's not a multiple of 30 or 45? Well, I'm going to use the calculator. So the important thing to understand on the calculator is it has different modes on it. The calculators are used in all my classes, so you can't guarantee if you pick up a calculator it's going to be in the same mode that you left it in, or even that you get the same calculator. So you have to know how to set the mode based on the problem you're doing. So on my calculator, I have a button, let me show you, at the top that says mode. And when I press it, I have two choices that I can pick as far as the mode about my angles. I can either put it in radians or I can put it in degrees. Okay, on this type of calculator, you just highlight the one you want, you click enter, and now it's in radians. And what's nice is mine actually says the mode it's in right at the top, and that's on every screen. So I always know I'm in radians, no matter what screen I'm using on my calculator. Okay, I'm going to put it back in degrees. So it's back in degrees. And if you're using one of my calculators, there's a button at the top that says, I think it says DRG. Can't see it that well, but it says DRG. It's right next to a blue button that says second. And if you press DRG, what comes up is three choices. It looks like this. So this got one more option than the graphing calculator. Degrees, radians, and gradients. Okay, we don't really work with gradients, but we do work with degrees and radians. It underlines the one that it's currently selected with like 3 dashes. So if you want to pick a different one, you just use, there's 2 arrows at the top. You press the arrow, and it'll change what mode you're in. And I think you just have to hit enter. Yeah. So you press the DRG button, press the arrows, underline the one you want, and then press enter. And this calculator in the lower right, it says DEG. So you know you're in degree mode if it says DEG. If it says RAD, you're in radians. If you have a calculator that's a little different, you can just check with me and we'll figure out how to change the mode. Right, but that is something you have to know how to do for the test. Okay, so if you come up and you're like, I don't remember how to change the mode, well, that's what I just taught you. Okay, so you can ask me tomorrow or today, but not during the test. Edge Elastic has a calculator as well. If anybody wants to see it, what we could do is just make like a practice question for tomorrow, and you could go on Edge Elastic and try that calculator. But I just get used to whatever calculator you're going to use. All right, so let's look at a question. So it says evaluate the sine of 18. If you don't see any directions, generally rounding to 2 decimal places is enough. But on the test, I'll try to make sure I write how many. All right, so the first thing we look at is 18 a multiple of 30? No. Is it a multiple of 45? No. So then this is not a problem we're going to be doing on the unit circle. To do the sine of 18 on this calculator, I press the buttons in exactly the order that it's written. I press the sine, I press the 18, close my parenthesis, and then hit enter. and that's how you do the sine of 18. It's about 0.31. So I press sine 18, and then I pressed enter. On this calculator, it's a little different. It's backwards. Instead of pressing the sine and then the 18 and then enter, I actually do the 18 first, then the sine function. So it's exactly the opposite order. I still get the same thing, but I think this is much easier to use. If you can just type it in the order you read it, rather than having to type it backwards. My calculators that you use, you type it in the way you read it. Okay. All right, so make sure when you try that on your calculator, if you're not getting 0.31, you're not doing it right. Something's wrong. Okay. Let's try this one. Cosine 356. Again, not a multiple of 30, not a multiple of 45. Multiples of 30 have to end in a 0. Multiples of 45 have to end in a 5 or a 0. So if it ends in a 6, it's not a multiple of 30 or 45. All right, so let's try it. Cosine 356. And again, this problem says degrees. I know that because I see the degree symbol. So your calculator should be in degrees. What do you get when you do that? Cosine 356. Yeah, go ahead.
0.1, or it'd be 1, which is 1.0, because it's 0.997.
0.997. So yeah, that would round up. I'll do 3 decimal places on that one just because that's a little weird the way it rounds up. But that would be 0.998. Okay, if we went to 3. If you went to 2, then it would be it would round up to 1. Cosine 356. What's different about this one? Yep, it's in radians. And if you're looking for some giant description that tells you it's in radians, you're not going to find it. The way you know it's in radians, you don't see that. That's the only thing that's going to be different. So you have to look for that on the test. So first thing I'm going to do this time is I'm going to go to mode. I'm going to change it to radians. And I'm going to do tangent 2.4. Okay. And what do you get when you put that one in? Justice?
Negative 0.92.
Yep. I got the same thing, negative 0.92. If you accidentally leave your calculator in degrees, it will be wrong. It's not right. What I would probably do is, if I was taking the test, I'd probably look for all of these problems, and I'd look for all the ones that are in radians, and just do all of those first. So I don't have to go from radians to radians and degrees. I'd just get all the radian ones done, and then I'd go back and do all the degree ones. But do it however you want. All right. So this is what I was just talking about. Now it's back in degrees, so now I got to change it back again. So go to mode, put it in degrees, and I need to find the cosecant of 247. Okay, so if you're using one of my calculators, look at it, or look at the graphing one on the board. Do you see a button that says CSC? No, there isn't one. You're not going to find a button that says CSC, SEC, or COT. How have we been finding the cosecant all week? What do we always do to find that one? Yep. It's the reciprocal of sine. That's exactly how you type it in. 1 divided by sine of 247. That's the only way to type in CSC. 1 divided by the sine. Then you should get negative 1.09. So that's cosecant. Any questions on that one? Right. How about this one? Anyone think they can tell me what I need to do to get that typed in on the calculator? Justice?
Would it be 1/cos 6?
So 1 divided by the cosine of 6,
Yeah.
just like that?
Well, it has to be in radians.
I have to be in radians.
Yeah.
So on my calculator, I can still change the mode before I hit enter. Some calculators, you have to change it before you start typing it. But I changed it to radians, so I'm still okay. And you should get about 1.04. And last one, cotangent of 13 degrees. How would I put in that one? Noah?
You wanna go into degrees first?
To degrees again. All right.
And then 1 dash tan.
Yep, 1 divided by tangent of 13. You should get about 4.33. One thing that comes up on this calculator and one of mine, that's like the scientific ones if you borrow them, there's a difference between this symbol and that symbol. One of those is a minus, meaning you want to do subtraction. One of them is a negative sign. On some calculators, that's the same thing. On mine, it's not. This is a subtraction sign. So if you want to type in -6, you don't do this. The subtraction sign and then a 6. Subtraction sign means to take 6 away from the previous answer you had on the screen. If you want to do a negative, you use the button right below the 3. -6. Okay, so just make sure you know the difference between the minus and the negative. They're different buttons. Okay, any questions on that? All right, so that pretty much covers everything on unit circle trig. So those are the homework problems for tonight. You've got about 15 minutes or so to get started. If you don't have a calculator, 67 to 81, I would recommend doing those right now because you need a calculator for all of those. And we're not doing these last two. So it's just 49 to 57 odd and 67 to 81 odd. Reminder, if you still need to take the test from last week, you have 2 more days to get that done. Periods 1, 4, 9, I'm here. I'll also be here tomorrow after school.